Okay, so I guess my microphone is working. We're going to compress this talk a little bit just to get more on schedule. So it'll be 18 minutes long. So instead of the 22. So we'll see if we maybe have to skip a few slides. So this talk today is about scalable automatic machine learning with H2O. So we will talk about all those things. And I just want to introduce you to the H2O AutoML team. So the term AutoML is sort of a generic term, but we have a tool called AutoML, which is part of the open source H2O platform. And myself and my colleagues Sebastian and Andre, we are the ones who work on this project. So just if you have a sense of who we are, say hello. So first I just want to explain a little bit about what is automatic machine learning. And if you came to the hands-on training yesterday, some of this stuff, and you heard me talk, some of this stuff will be a repeat of that, but I have some new stuff in here as well. But the first part you might have heard already, but I just want to give an overview of what is automatic machine learning. So essentially the idea is to automate all the steps of the data scientist. So that would include things at the beginning of the process like data preparation. That would include generating or training a lot of models. And then optionally at the end, you could also ensemble some of these models together if your goal is to get the best performing model. So there's, again, I mentioned the term AutoML is a generic term. So it could be used to describe a lot of different techniques. So just if you have some, if you're sort of new to the field or new to the term AutoML, there's a blog post that I wrote a few months ago that you can see here. It's on our blog at H2O, but it's just a blog to sort of demystify what are all the different types of AutoML and all the different tools and sort of when do you use what tool for which thing. And yeah, because it basically is determined by what does your data look like. If you have image data or text data or more traditional tabular, numeric, or categorical data, that will determine what type of AutoML techniques you'll use and what type of tools you'll use as well. Okay, so this is just a little bit more detail about the other slide that I had before. So data preprocessing could include things like imputation of missing data, one-hot encoding of categorical data, standardization, different types of things to reduce the dimensionality if you have very wide data, so like feature selection or feature extraction. And then there's more advanced types of encoding schemes if you have categorical data. So there's all different types. So one type that we've added recently in H2O and that we also make heavy use of in driverless AI is called target encoding. So this is good if you have a categorical column that has a lot of different levels in it. And the example that I like to give sometimes is zip code. So zip code is something that has like 40 or 50,000 different options. And so if you apply something more standard like one-hot encoding to that, you'll expand your data set into an extra 50,000 columns, which is not a good position to be in. So when you have these what are called high cardinality or many levels or many categories for a single column, you want to apply some sort of data processing technique so you don't, because machine learning algorithms don't like those columns essentially. So then in order to select the best model, you would have to generate quite a few models as well. So there's different ways that you can do that. So the most standard approach would be grid search or random search. That's a way to train a bunch of models and very quickly. Then there's something called Bayesian hyperparameter optimization, which is a different type of approach. And it's whereas you could parallelize a giant grid search with Bayesian hyperparameter optimization, it's a sequential process where each time you're getting a little bit closer to like the best model. So from a computational perspective, there's different advantages to those two. And then for, once you have a number of models, if your goal is really to get the best model that you can get, then that's almost always going to be an ensemble of multiple models. And if you've seen Kaggle.com or seen people participate in Kaggle competitions where that is the ultimate goal, is just to get the best performing model, like almost every winner of Kaggle is some big ensemble of models. So there's different types of ensembles. So the type that we do in H2O is called stacking, or stacked ensembles. It's also called super learning. It's all the same technique, it's just a few different names to refer to it. And there's another type called ensemble selection, which is just a different approach, a greedy approach to ensembling. So I'm just going to show you the same slide, but highlight some of the things that we have in H2O right now, or H2O AutoML right now. So we have the first line of things, that's in all H2O algorithms, so we get that for free in AutoML. And the last line, target encoding, that's on our roadmap. So we have that now implemented in H2O. So now we can put it into H2O AutoML. So that's something that we're working on right now. And then the way that we go about producing models and producing a good model is that we apply a random grid search to a bunch of different types of models, and then we ensemble them together into one, either one big ensemble or a more lightweight ensemble where it's just a subset of the models. And so why do we choose this approach? So one honest answer is that we have all this stuff already in H2O, so we build on top of what we already have. But the truth is that these two things work really well together, so they fit nicely together, because stacking works really well when you have a diverse set of base models to create the ensemble. And so if you're using randomness to generate models, then by nature those models will be pretty diverse. So that's a good way to combine these two things together. And this is just a little bit more about stacking. So essentially what stacking does is it uses machine learning to learn what the best combination of the base learners is. So it's not like just taking an average or some other weighted thing. It's actually using another step of machine learning to learn how to combine those things in an optimal way. And that's why it works so well. So this is just kind of an overview of what we have in H2O AutoML. I have a little sticker up there. These are stickers that you can find. It's a little hex sticker. We have one for AutoML. So if you like that sticker, you should go get one at the H2O3 booth out there. I just want to make sure you know that they exist, because I think they're very cute. And I have a new laptop, and I haven't put any stickers on yet, but that will be the first one that will go on there. Side note. So anyway, what is in AutoML? Basically, we have all the basic data pre-processing, and I said we train a random grid of all the different types of algorithms that we have in H2O. And this is the point of the process in which we put sort of our expert knowledge into the system. So we decided which of the hyperparameters for each of the algorithms should we tune, and then what are the ranges for each of those parameters? Because that's kind of the tricky part of data science is, as a experienced data scientist, you have to kind of know all the algorithms, you have to know when they're useful, you have to know which hyperparameters you want to tune when your data is a certain way versus another way, and then what are those ranges, and that's kind of sort of an art to machine learning, and you learn just based on experience, but that's something that we've put into the system, is to try to guide that a little bit better if you don't know where to start. And so then we tune each of the individual models as well. So some of the algorithms are iterative algorithms, so you can overfit if you keep training too long. So we want to make sure that we stop that before we overfit, so we do some of that automatically as well. And then I mentioned there's two ensembles that get trained at the end. One is includes all the models that you've trained, and generally that's the best model almost all of the time. It's not always the case, but often that's going to be the winner. And then one, which I mentioned, is just the best GBM, the best XGBoost model, the best deep neural net, the best GLM, best random forest. And that would be what we call the best of family ensemble, which is just more of a lightweight ensemble. If you're trying to put an ensemble into production, you might not want to put one that has 100 or 200 models in it. Maybe you want to just have something more simple. And then what you get back from AutoML is what we call the leaderboard. And that's just a ranked list of all the models and what their performance was. And so I'm just going to quickly show you what is the interface to AutoML and all of our different interfaces. So this is Flow. This is our web GUI. So essentially, it's very point and click. You just upload a data set, and you tell it what is the column that you're trying to predict. And then we have some options for AutoML. They're mostly all listed right there, but you don't have to touch any of them. They're sort of just there for advanced users. If you want to tweak with the AutoML algorithm itself, you can turn on and off different types of algorithms. You can have more control over how it does the early stopping. You could specify which metric you're interested in. So if you have like a binary classification model, we will make some assumptions that maybe AUC is the thing that you care about, unless you tell us otherwise. So maybe you're interested in minimizing log loss. Well, then you could tell AutoML that that's your goal instead of maximizing AUC. So there's things that you can tweak. And so this is just what it looks like in R. So it has the same interface or same look and feel as all the other H2O algorithms. So we have an argument called training frame, and the Y is where you specify what the column name for the response is. And then for AutoML, essentially how you, the main thing that you have control over is how long do you run it for. So you can say, you can specify by time. So in this case, I'm saying, run this for 10 minutes and then give me your list of models. You can also specify the number of models that it trains. So there's a couple different ways that you can tell AutoML what to do. And this is what it looks like in Python. It's the same idea. It's just a little bit more Pythonic interface where we first create the object of type H2O AutoML, and then we invoke the train method on a particular data set. And so then we end up with the leaderboard at the end. So that will look something like this. So it'll just be a data frame, essentially. And the first column would just be the ID of the model that you trained. And so this is just meant to be concise. So for each of these models, you could look at what it was. So you could grab the model by ID and then look inside of it and see, it's an XGBoost model, but what was the, learn rate or the, column sample rate or whatever. It has all the values there. And then it's ranked by the cross-validated performance metric. And for binary classification, the default is AUC. Okay, so just a few tips before I move on. So I mentioned already you can exclude certain algorithms if you know in advance that you don't want to use them. And the runtime is set for 1 hour, so that's just there sort of for safety reasons, because you don't want it just to run forever, and that could be very expensive on Amazon if you forget to stop it. So if you want it to run for more than an hour, you need to change the max runtime seconds. For reproducibility, if you use the max models parameter, it will be reproducible because with a runtime in terms of time, that might not produce the same exact thing the second time you run it. Maybe there's fewer resources available on your machine, et cetera. And then another tip is if you're going to run AutoML for a long time, it's going to train a lot of models, and so you need to have enough memory to store all those models in the H2O cluster. So in the H2O init command, when you start it up, just make sure that there's no way to really know how much memory you need, but just sort of use as much as you have on your machine and see if it works, and if not, then either get a bigger machine or run it for less time. Okay, so I just want to make a few comments about how we've been improving the AutoML algorithm. So one of the big things that we added recently, so in the latest, so for H2O, we're at 322.1.3, I think is the latest version, but basically 322 is the latest stable. And in this version, we had a big boost to AutoML because we added XGBoost. So for a while, we have had XGBoost inside of H2O, but it wasn't yet ready to be put in AutoML. And so now that we've done that, we can see that it's actually improved the performance quite a bit. this is just one simple example. So there's this Higgs data set that I probably overuse for demos, but basically on the AutoML web page on our user guide, this is the same data set. So if you want to replicate this experiment, you could. Essentially, it's a 10,000 row data set, a binary classification problem, and I ran AutoML on the last 3 versions that had, well, there's a bug that we fixed, which was fun because the performance increased when we fixed the bug. So that was the last version that we tested. So if we compare these 3 versions, you can see on this plot here that we're improving over time. And of course, this is just one data set, so it's hard to make assumptions about what that means. But what you see here is the line on the top. So on the x-axis, we have the version numbers. On the y, we have performance in terms of AUC. And so the top is the stacked ensemble with all the models. The one below it, the green one, is the best of family stacked ensemble. And then the blue one below is the top single model. In 320, that would have been an H2O GBM, and now it's an XGBoost model in the next 2 versions. So that's just, yeah, so we're trying to improve our performance all the time by benchmarking and tweaking what's inside the algorithm. So I just want to mention a few things about what we're going to add in the future. So, the 2 things that we're working on right now are the top 2 items. So we've added target encoding, I mentioned, to H2O, and we've added a new type of stacked ensemble called blending. So it's the same idea. You're learning the best combination of the base learners through a meta-learning algorithm, but the regular stacked ensemble algorithm uses cross-validation. So if you have like time series data, you don't want to, it's probably not going to work so well because cross-validation and time series don't really go together. I'm not going to talk about why, but just know if you have time series data, there's now a new type of ensemble in H2O called blending. Essentially, there's just a blending frame parameter in the stacked ensemble function that if you pass it a piece of data, it'll do blending using that data. So that's something that we're going to add to AutoML. And then, of course, we're going to do automatic target encoding so that you don't have to think about, do you have a zip code in your data? Do you have other columns that are going to, blow apart your machine learning algorithm? So we want to do that automatically. Then other things is just better support for wide data sets. And we'd like to support text input directly because we have Word2Vec in H2O. So it's just basically adding a little wrapper around that so that we can read the text in and then apply Word2Vec and then proceed with AutoML once the text has been encoded. And then there's just a few other things on here. I'm running out of time a little bit, so I want to just skip ahead to a couple, 3 more slides. So I mentioned some benchmarks. So we're working with this group called openml.org. So fellow AutoML researchers, we're all interested in benchmarking our systems against each other because we want to know who's winning. But that's kind of a simplification of things because it's not really, there's never going to be one tool that is better on all data sets. So the idea here is to divide up the space of data into sort of subsets of interesting pieces like wide, sparse data, dense, tall, skinny data, big data, small data, and then find out which tools perform, and how do they perform against each other in those circumstances. So this is something that we're working on right now, but it's not complete. But we're essentially building a benchmarking system to benchmark open source AutoML tools, which you could then use to benchmark closed source tools as well, because the code's available. And then I just want to point out a few things, how people are using AutoML in the wild. So I just screenshotted a few tweets. The first 2 are from yesterday. So Matt Dancho has given a talk at RStudioConf about using H2O AutoML along with the Tidyverse and Shiny to reduce employee attrition. So he actually has a company called Business Science, and he does training, and he uses AutoML and H2O heavily in his training. So that's a nice talk by him. Mara, who's in the front row here, who works at RStudio, I don't know, she just tweeted this yesterday. just some application of using AutoML to cancer detection. So it can be used all sorts of ways. And this last one over here, I just put up there because people are using it as a teaching tool as well. So at the University of Oslo, they're teaching a course using AutoML. It's just a really easy tool to teach with because you don't have to get people to know everything about AutoML. And then one last slide before I get kicked off. This is a fun application of AutoML. So there's these three guys here. The middle guy was the consultant on the movie Moneyball. So they based the story on his life, and he now uses H2O AutoML to do what he does. And it was recently used to make a $20 million trade of some baseball player who we don't know who it is or what team, but that's what we were told. And so this is a whole series of presentations by Joe, who, if you go on his website and if you look at that URL, you'll find more information about that. And then I'll just leave this up here for a second. These are links to where you can learn how to use AutoML. There's tutorials and documentation. And that's it. And so I don't know that I have time for questions, so we'll just leave it at that. OK, thank you very much.